Okay, a ball of mass m is moving with certain velocity. Let us call that velocity as v1 bar. This is another ball of mass m which is stationary at t equals to 0. So this is m, this is m. Let's say this will hit this ball at an angle theta. So if it is moving in this direction and the impact is at this point, then it will be hitting at an angle theta. So let the angle of impact be theta. And after the collision, let's say the first object, okay, we will call this object A and this ball B. The first ball will be moving with velocity v11 bar, let's say, and the second ball will be moving with velocity v22 bar. So we need to find the relation between v11 bar and v22 bar. So given the masses are equal, so by applying conservation of momentum, we can write m v1 bar plus m into 0 equals to m v11 bar plus m v22 bar. So from this we will get v1 bar equals to v11 bar plus v22 bar. This is conservation of linear momentum. Conservation of linear momentum. Now conservation of energy. Half m v1 square is equals to half m v11 square plus half m v22 square. From this we'll get v1 square equals to v11 square plus v22 square. Let's call this equation as 1, this as 2. Now from 1 and 2, squaring 1 will get, so squaring 1 will get v1 modulus of v1 square equals to modulus of v11 square plus modulus of v22 square. Okay, sorry, these are modulus, so I should write it clearly. By writing v11 I meant modulus, so plus 2 times v11 bar dot v22 bar. But from equation 2 we have this quantity as equal to this quantity, so v11 bar dot v22 bar, which is equals to modulus of v11 into modulus of v22 into cos theta is equals to 0. Cos theta 1, let's say it's cos theta 1, it is after impact, and cos theta 0 is before impact. This implies cos theta 1 is equals to 0, which implies theta 1 equals to 90 degrees. So after the impact, they'll be moving at an angle of 90 degrees with respect to each other. So if they are moving in this direction, the angle between them is going to be 90 degrees. Angle between them is going to be 90 degrees.